One. Good morning or good afternoon or peace out, whatever you're doing. Hello, she's a hippie today and I'm a Hawaiian. I don't have tie-dye, but I have these shoes and I wish you could have seen her face. I mean, like I think the wonderful thing is these go with everything. Like even like,
I would argue that they go with nothing.
oh my gosh, you just are jealous because I have such.
You want to see my shoes?
Oh, you probably have some Chacos or something. Yeah, whatever. No fashion sense at all. Okay, so anyway, we're going to talk about the graphs of quadratic functions in this lesson. So let's just jump right on in.
And we kind of actually started this conversation in the last lesson where we were showing you how the zeros of the quadratic function were related to the graph of the function.
And we even started it before them when we were doing transformations of generic parent functions, of which the x squared graph was one of them. This is the basic parent function, f of x equals x squared, and it has an x-intercept of 0, 0. Okay, so it hits right here at the origin. Thank you for that. And it has, we have some information. We're going to start messing with it. But this also has something we call symmetry. The left half is similar to the right half. Oh, look at you being cute. This is what we call the axis of symmetry, not the axis of evil, but the axis of symmetry.
I've met some people in my life that were the axis of evil.
That's right. And the axis of symmetry is just the line that cuts it in half. Okay, that would be the mirror of the, okay? So, and I don't know why my origin point is sticking its tongue out at you, but you know, that's where we are. When this is, we're gonna warn you I'm gonna warn you right now, this is our 4th video today. We're recording a lot of these in succession, and this is our 4th video, so we get a little slap happy after this.
Yeah.
So watch out, man. It's probably gonna be a good video, or that one that you'll be able to laughing at us.
Yeah, you feel free to laugh at us because we are definitely laughing at ourselves.
Okay, so let's do this. And there goes Leo again. Hey, Leo. All right, so we're going to look at this from the perspective of transformations of that basic parent graph. We've already done this. What would you say this has happened if you were talking this graph A has done? What's the negative do, Miss Young?
The negative flips it over the origin. Remember, it's almost like Beyonce, but it's like sideways Beyonce. I don't know.
All right. So it takes it and inverts it or reflects it over the x-axis. What does the 2 do? That's what just the negative does. The 2 does what? Stretches it, which would make it appear skinnier. That makes it twice as tall. But since it goes on forever, we can't see the ends, but it does make the effect of being skinnier. All right, I'm going to skip that -3 because that scares me for a moment. What does the +5 do? It pushes it up, push it up, pump up the volume, or pump up the vertex. Okay.
No, people haven't done that since 1992.
Shut up. That's up 5. And then the 3, when I said scared me, was, what is that? Why did it scare me, Miss Young?
Because it's just like your ex, and it always does the opposite of what you expect.
Okay, so we are going to say flipped or reflected. I'm just going to be casual here. Stretch.
And that's vertically stretched. If you remember, we did talk about vertical and horizontal stretching both. This is on the outside of that square. And so this is a vertical stretch, meaning it leaves the x's alone and multiplies the y's.
And then what'd you say about the -3? That's a right 3?
That's a right 3. It's going to do the opposite of what you think. Instead of sliding to the negatives, it's going to slide to the positives.
All right, so now my vertex that lowest point on the x-squared graph is now actually going to be the highest point, but I'm not going to worry about that right now. Normally it would have been right here, right? But instead, I want to take it right 3 and up 5, or right up 3 and right 5. Either way, I would end up right there. Okay?
Yep. So he just slid that vertex using those transformations.
Okay? Now, this is my point on my graph, so I'm going to just kind of maybe go with, since I have the rainbow shoes on today, I can do it a different color. And then it's going to be skinny and down, skinny and down. I don't care if the graph is really rough, but I do care that you tell me that this point is at 3, 5. Okay?
And you could get really specific here. You could set it equal to 0, solve for the x-intercepts, plot the x-intercepts. You could plug 0 in for x, solve for the y-intercept. There are a lot of things you could do here to get a much more specific graph than this. But we're just kind of saying, like, what does a graph look like, and how do A, B, and C affect it in terms of transformations? A, H, and K. I don't know what I'm saying.
Yeah, so why don't we pause the video? Really, like, no, I'm kidding, not kidding. You're like, pause it. No, really, pause it and try problem B. Okay, we're back. This graph would have moved left 2 and up 1, so it would have been right there. Yes. And this one is not reflected over, but it's wider, so I'm going to have a wider graph.
Sheet thick.
I'm sorry, what?
Nothing.
Okay. At this point right here would have been at -2, +1. That's what you should have gotten. Okay? Be cool? And if you would explain those transformations, you would write them out. I verbalized them. You can rewind what I said. Okay?
Rewind what I said.
Okay, so moving into the summary of that. This is what we actually call vertex form. Okay? And there's some things you should be able to pick out of this graph. To me, this is almost like, remember from lines in like algebra 1, you did y equals mx plus b, you could tell some information about it. There's some key things you can pick out, like M told you about the slant of the line and B's y-intercept. This is kind of like that. If that leading coefficient, that A value is what we call leading coefficient, if it's positive or greater than 0, open upwards. If it's negative or less than 0, it'll open down. The vertex is at H, K. So we have that backwards X thing going. And the axis of symmetry is a vertical line. Remember, vertical lines have the equation X equals. I didn't draw the vertical line, but the vertex and the axis of symmetry often will always share the X coordinate. The minimum, if it's an opening upwards graph, it'll have a minimum at K. The lowest value on the graph will be K. And if it's a negative leading coefficient, it will have a maximum, and that maximum is always the K. So this form is like super easy and super informative, okay? Like, it tells me a lot about the graph. Now, it doesn't tell me about the intercepts, and when I want to find the x-intercepts, that's what we had to do in the last section. But I could even, it's already like, it's incompleted the square form, so I could find the x-intercepts by doing the square root thing, okay?
Make sure you note that when you pull the vertex off of your form, this negative right here tells you to take the opposite of that number. So if the number's 2, then you would pull off -2. If the number were -7, then you would pull off +7.
Yep. And somebody's going to mess it. I bet I would love to have a class where that nobody ever got.
Not one person made that mistake. It'd be magical.
Magical. You could be the first class if you actually listen to the words that are coming up. Oh, never mind. Why won't they listen to us? What did I just say? What?
Bobby's angry.
No, I spent 23 years being ignored. I would like somebody listen to me. Nobody hears what I say. Nobody cares. All right, so if it's not in vertex form, we can get it into vertex form by kind of quasi-doing completing the square. Why are you shaking your head at me?
Oh, because I don't want to complete the square.
Oh, you don't want to? Well, too bad. All right, I'm going to do it anyway. You know why? Because I'm a grown-up. I get to do whatever. I can do whatever I want. I'm a grown-up. All right?
Whatever he likes.
So if I do completing the square on this, I'm going to do x squared plus 6x. What number would I need in the completing the square process? I have to take half of the b, and square it. So half of 6 is 3. 3 squared is 9, right? I need 9. I really want there to be a 9 there. Then I can do that square thing. So I'm going to do that. I'm going to put 9 here, okay? This one's a little different when we're doing it in terms of a function though, okay? So I kind of want to put a space here and put a 9 there, right? I kind of want to.
I like it.
But I have a -6 here. Well, I can't willy-nilly go putting a 9 in a function. So if I put a 9 there, I got to put a 9 on the other side. But I don't want to mess with this. Like that f of x thing is really pretty, and it's really nice. And so another way, like I don't want to do this because now I'm messing up my prettiness. Okay, it'd be like wearing one of my shoes and then wearing one of her shoes. I'm not wearing none of those grandma clogged shoes or whatever she has on. All right. So what she did was she came up with a different way of doing it. So if I add 9 and subtract 9 all at the same time, what have I done? Nothing. A big old squadouche. Okay. I've done nothing. So I'm going to treat this part right here, and she's going to deal with the other part. Okay. So x minus x squared plus 6x plus 9, that there equals x plus 3, the quantity squared. And Miss Young's going to be able to add -6 and -9 and get 15. And guess what we're in vertex form? The vertex is at -3. That's what she was talking about a moment ago, -15.
Which means the axis of symmetry, which is the line that goes right through the middle of that parabola, is going to be x equals -3. Remember, you can just pull the x value straight off the vertex.
Okay. So I could, and I also know this graph would be opening upwards. How do I know that? Because there's a 1 there, and that's bigger than 0. Okay? So I could sketch a rough graph pretty quickly. Now, yes, I could throw it in my calculator. This about can I just throw it in my calculator? Yes, you could throw it in your calculator, but
See how mean? See, he's mean. He's mean to you.
No, you can, but how many times have I air graphed in this class? I think I've done it more than a couple times. You might, if you threw this in your calculator, it wouldn't be on the home screen right away of your graph. You'd have to do a little bit of adjusting. So I'm making informed decisions about where I know I want to have a sense of the graph before I grab my funny-enabled calculator. Okay, I love calculators. I'm a calculator geek. Okay, so all right, now Miss Young don't like no completing the squares. So I got something for you, Miss Young.
He's got something. It looks worse than it is, guys. I promise. It looks worse than it is.
And honestly, it really looks, there's only one thing that you really need to worry about, and like being mathy so I don't get kicked out of the math club. Okay? Because there's we have a math club. We actually do have secret meetings where we do math handshakes and stuff like that.
No, he's straight up lying to you.
Okay.
He is straight up lying to you.
This is really all you need to know, and that's actually like the quadratic formula without the square root jump.
Yeah.
Okay. It's, if we do negative b, forget all the rest of it. Okay. So if you find that number, that's the x coordinate of the vertex and the axis of symmetry. Well, once I have an x value, I can get a y by plugging that x value back in. So I'm not even worried about the other part of this, all right? Let's just jump where I don't want it, okay? So
I don't even think about that second part of this
at all. But I didn't want to get kicked out of the math club. Okay, I told you that, all right? So I'm going to go back to my pink because I like my pink. So I'm going to do the negative b over 2a thing, the negative of b over 2a. And this is, again, just like the it's the quadratic formula without all the plus or minus from. So it would be the negative of 8 over 2 times -2.
I see a couple of negatives in that problem, so let's make the whole thing positive.
Right? And on top, I'm going to get 8, and on the bottom, I'm going to get 4. So this is just going to be a big old fat 4. Okay? So I now know my axis of symmetry is, that actually is my axis of symmetry, is x equals 4.
8 divided by 4 is 2.
That's what I said, too. Thank you.
You actually, I think, said 2. You just wrote 4.
Good. You know, it's my first mistake ever. Let me be. All right. I don't think we've actually spent this much time talking as teacher. Like Miss Young and I we've taught together, but like we haven't actually seen each other teach. It's kind of scary, you know.
It is.
So
Yeah, we taught next door to each other for a really long time. But actually, guys, Mr. Bobby was one of my very first teacher friends when I first started teaching, like almost 17 years ago. I met him at the very beginning, and we just been trucking along all these years.
Years later, now we're doing it. But that line right that I just drew, now that's not part of the graph, but that's going to be my axis of symmetry. Okay, I'm not going to keep that there because I think it will confuse us as part of the graph. But that's what it means. That's the line that I would have down the middle. Now, what she's doing right now is I know the x-coordinate of the vertex. To find the y, I just have to plug 2 into the equation. So she's doing -2 times 2 squared plus 8 times 2 minus 5. And we need to do some math here. Oh, gosh. The first one's going to be -8. Okay. Oh, I got to get pick my pen back up, silly Mr. Bobby. So this
-8.
-8 plus 16 minus 5. And all of that adds up to a big old 3, I think. Right?
Yeah.
So that's going to be right here at 2, 3, and that point would live right there on the graph. Now, what else do I know about this graph?
Going down.
Going down, and because of now this number right here is the same, would be the same if I put it in the vertex. So I'm not making you put it in the vertex one, but I know the graph is going down and it's going to be skinnier. So it's going to go like this and go like this. Okay? So now I want to talk about the range. The range are the y values. So what are all the possible y values that I can get out of this graph? Well,
Mr. Bobby, why are we not talking about the domain? You skipped the whole domain.
I didn't want to do, well, because, all right, well, what is the domain, Miss Smarty Pants?
Well, there isn't a single number I can't plug into a quadratic equation.
That's why, because it's not really interesting. It's all real numbers. It goes on forever. So yes, the domain, I wasn't really concerned about that because the domain, I can't have a problem. I don't run into a problem. So how do you want me to write that? You want me to do the infinity, negative infinity, or the big?
Yeah, that's what I like. It goes left forever and right forever.
So it goes to negative infinity to infinity. Okay.
Every single time, and guys, I don't know what the test is going to look like because it's not written yet, but if for some magical reason we ask you, what's the domain of this quadratic equation? The answer is always all real numbers or negative infinity to infinity.
And that's a maximum. So that in terms of the y values, the y value of the coordinate is the maximum. So the range would be less than this y value we found a minute ago, less than or equal to 3. And if I wanted to write that in interval notation, I would do negative infinity up to 3.
Now, guys, this is so important because people mess this up all the time. If you put 3 to negative infinity, I will mark it wrong. Mr. Bobby will mark it wrong because interval notation goes minimum to maximum. You can't go from 3 to negative infinity. Like, you can't write it like that. I understand that you can see it like that, but you can't write it like that in this notation. It has to go minimum to maximum. You mad though? You mad?
I don't like it. I don't like it. I don't like it one little bit.
And then also the bracket. Remember, the bracket means that he's including 3 in the domain. It's important. I mean, the range, I'm sorry.
I'm so mad you made me write that. All right. Don't do it. I don't put the figure out very much, but that one I did. All right. Intervals of increasing and decreasing are parts along the x-axis where the graph is going uphill from left to right. So the graph that I drew would be increasing up to the x value of the maximum, which is at 2. So it would be from 0, we talked about not 0, infinity, up to and include up to 2. And when we talk about intervals, we don't include the max. You could, but I really don't want you to. 2, to infinity is where it's decreasing. From that point 2 on, the graph is decreasing, and it's Wilson.
Don't forget to put the negative in front of the infinity symbol when you're doing the increasing, because remember,
Yeah,
negative infinity up.
yeah. So I was still troubled by Wilson. All right. Okay. So let's move into finding a maximum and putting this in a this really isn't a hard section. The first thing, the vertex was the transformation. We kind of already did the first ones when it's in vertex form, but we just formalized it. But that point of the negative, that thing of the negative of b over 2a is how you can handle the standard form. Okay. So let's do this problem, and we're going to do a rocket that is launched launched with initial velocity of 100 feet per second from the top of the hill. That's 20 feet high hill. And we have an equation, S of t equals negative 16t squared plus 100t plus 20. I don't care where that came from right now. That's physics, and physics is like, dirty math, and I don't really care. I'll just take it from wherever.
Because it's applied.
No, gosh. Yuck. All right, so what I want to do is I'd like to see this graph and find the vertex. Well, I know that's what I'm trying to do, is find how high it goes. I want to, basically, this question is asking you to find the vertex. Okay, now I could do this by hand, or I could do this by the technology. Since we've already done a couple problems by hand, I'm going to do it with the technology just for kicks and giggles, okay? Just so you can see that. So let's open my calculator, and I'm going to clear out for drawings. So actually, let me get out of the Google presentation so I can type in the equation again, because this is our 4th video of the day, like I said, and we're a little slap happy. Actually, I don't think we've been too bad in this video, but it could be worse. So I'm going to make the graph, and I'm going to type in the equation, and I put t in there on purpose because you'll see that a lot, and it really freaks people out. But I need to put squared. And I really tried hard to make my fonts readable so that you wouldn't confuse the t with a plus.
With all those large numbers in that equation, Mr. Bobby, I'm a little worried that our window might be wrong.
Well, that's another thing that's important. That's why I would like to, if I did negative b over 2a, I'm going to take 100 over 32, and it's going to happen around 3 something, right? 100 divided by 32 is somewhere, because I'm going to have some negatives and negatives. So, but my values are going to be pretty high, and I'm thinking I might get an air graph in here. Can I air graph again?
I'm nervous. Well, I don't think that's gonna happen because it's upside down. So you're potentially gonna see something in there.
Yeah, but I don't know if you noticed, I put a T in there and it yelled at me. Because
we had a whole conversation about T. Is that what you did?
I did what I did. I did what I said not to do. I bet
you did that on purpose because you're teaching.
That's why I'm doing. And I put 100 T in there, in error.
Right.
I put 100 T's. Thank you for pretending like I meant to do that, because they'll never know. All right. Now when I hit enter, I don't get it to do air graph, but I don't get a helpful graph. And this is what Ms. Young was trying to say a minute ago. And I entered it incorrectly. I know that I did, but I'm not, because I can see that's the right equation, right? But I'm not seeing the top like I want, so I need to go on up there. And the nice thing is, I know at least that it's at 20. Now, it was at 20 feet when it launched, and then it got higher. So I know I need to go like more than 20. Right now, I'm only going to 6.67. That's what the calculator does on its own.
Not enough.
Not enough. So I need to probably go up like at least to 40 or something, 50 maybe. So I'm going to try it.
This is not an exact science here. You could plug negative b over 2a back in to actually just find out this number. But like, just keep guessing it. 50 wasn't enough. Well, that middle number is 100. Maybe it needs to go to 100. Let's try 100 next.
All right, let me try.
If that's too much, I can bring it back down. Oh, still not enough. Maybe 200. Like you're going to good chance you're going to just guess wrong the first few times. Don't give up just because you've guessed wrong the first few times.
Okay. So there's a couple different ways of finding a maximum on a graph. We can do the analyze graph feature, if you're familiar with 84, you may have done like a left-right guess thing, and that's kind of what this is. But I'm a big fan of just menu trace, graph trace, because
And I would have immediately just analyzed the graph to find the maximum. Like it really just, it's whatever.
whatever floats.
Yeah.
And the maximum occurs 3.12 seconds after launch. Okay, and the rocket will achieve a height of 176 feet. Now you can use the calculator here, but I need you to be able to interpret. If I asked you and allowed you to use your calculator, I'd be fine with you putting in the equation, changing the window, finding the maximum, using the analyze graph or the trace. I don't care, but how do you answer it for credit? Okay, I don't have a ton.
Do you want them to graph it on the test, like with a quick sketch showing where they're getting their answer, or do you not care about that?
I would like to see a graph, and I would like to see a maximum at 3.12, and it was 176, I believe, right? Was that?
Mm-hmm.
And then I need you to interpret, because like, okay, you've done a bunch of technology, but you know, I could teach your grandma to do that, you know. But
so you might want to say something like the time or the rocket reached its max height of 176, is it feet?
Yes.
I'm not spelling things right. In 3.12 seconds.
Yep. After launch, or just 3.12 seconds. And we can't see it yet because but she's typing it. Now you could write that, but she was being cute. So, and that's fine. I'm totally fine.
I was not being cute. I have to use my mouse pad to write, and it's a pain. So I was making my life easier.
So the interpretation to, getting a sketch, getting a graph, interpreting and knowing what to do, and then how to interpret what you're finding. That to me is actually really doing mathematics. Anybody can throw something in the calculator and find a point. But
less about the method in this case, more about, can you get to a right answer, and do you have any idea what that right answer means?
And these numbers aren't awful, we could have done it by hand, but I wanted you to see a little bit more complicated problem and how it could be done with technology, and how I could ask you to interpret things. Okay. Yep. So I am going to, I think
bring us back to your slideshow, and then show us the homework, Mr. Bobby.
Well, I think we're pretty much done. Well, actually, I don't even need to do that. I can just click here and show you the homework. So I hope you have a happy day. We got like a couple more sections in this module, but you'll have a good.
Keep it groovy, baby.
Mm-hmm.